All right, today we are going to talk about something that is, well, it's literally everywhere. It governs everything from the tiniest atom to the biggest galaxy. Energy. So let's get into it, and we're going to trace this massive story of the universe by starting with something you've probably done 1,000 times.
Okay, so I want you to just picture this for a second. You're lifting a box off the floor. Super simple, right? But believe it or not, in that one little movement, there's a whole universe of physics going on. Yeah, you might just call it a chore, another thing to do. But in the language of physics, what you just did has a very specific and pretty powerful name. You performed work.
Here's what's so cool about it. In physics, work has nothing to do with how tired you get or how much you sweat. Nope, it's all about the results. It's literally just the force you use times the distance you move something. That's it. So when you lifted that box, you applied an upward force over a certain distance, and bam, you have officially done work.
Okay, so by doing that work, you basically pumped energy into the box. And now that energy is just sitting there in one of two possible states. Right now, as you're holding it up high, it has what we call potential energy. It's stored up, just waiting. But what happens the second you let go? Whoosh! All that stored potential energy instantly transforms into kinetic energy, the energy of motion.
But, the energy in that box, that's just scratching the surface. It turns out energy is this incredible shapeshifter, and it's constantly changing its form all around us all the time.
I mean, it is just incredible how many different faces energy wears. Our box, that's mechanical energy. But so is the heat in your coffee, that's thermal energy. The juice in a battery, chemical energy. The electricity lighting up your screen right now, and even the nuclear energy locked deep inside an atom. They all seem so different, right? But they're all just different flavors of the exact same fundamental thing.
And this leads us to one of the most fundamental, absolutely unbreakable rules in all of science. Seriously, this is a big one. You just can't create energy out of thin air. And you can't destroy it either. All you can do is transform it, change it from one form to another. This rule it's universal, no exceptions. And once you start looking for it, you see this chain of transformation happening everywhere. Let's take a car, for example. It all starts with chemical energy, right? The stuff in the fuel. That fuel burns, creating thermal energy, basically a tiny controlled explosion. That heat then creates mechanical energy, which pushes the pistons and turns the wheels, and that becomes the kinetic energy of the car actually moving down the road. It's this perfect, beautiful chain reaction.
So for a long, long time, scientists got this. They understood all these transformations. But they thought there was one wall you could never break through, one rule that was set in stone. That is, until a guy named Albert Einstein showed up and revealed the ultimate transformation.
You see, the old way of thinking was super simple. Mass was mass, and energy was energy. Stuff was stuff. A rock is a rock. A beam of light is a beam of light. They were in two totally different boxes, two completely separate ingredients of the universe. Or so they thought.
And then, with just 5 little characters, Einstein completely rewrote the rulebook of the universe. E equals mc squared. We've all seen it, right? It's on t-shirts, it's everywhere. But what is it actually telling us?
Well, it tells us something so profound, it completely flipped our understanding of reality on its head. It says that mass isn't separate from energy. Mass is energy. It's an almost unimaginable amount of energy, all packed down, super concentrated into the form of matter. They're not two different things. They're just two sides of the exact same coin.
So, why so much energy? What's the secret sauce here? Well, it all comes down to that little c in the equation, the speed of light. And that number it's just massive. It's almost too big to wrap your head around. But the equation doesn't just use that number. It asks us to square it, to multiply it by itself. So that c squared part, it's not just a multiplier, it's an explosive amplifier. It's what tells us that even a tiny, tiny piece of mass is hiding a truly staggering amount of energy.
And this mind-blowing discovery wasn't just some abstract theory on a blackboard. Oh no, it unlocked a power unlike anything humanity had ever seen. A power that, as it turns out, has two very, very different faces.
This one idea, this single principle, has led us down two completely different paths. On one hand, it gave us nuclear weapons. It's a science that unleashed unthinkable destructive power on cities like Hiroshima and Nagasaki. But on the other hand, that exact same principle allows us to build nuclear power plants, like the Ruport plant, to generate huge amounts of clean, constructive energy that can power our world. Okay, so let's bring this all full circle. We started this whole journey with something super simple, right here on Earth, and we've ended up at the scale of the entire cosmos.
Remember that box we were lifting? The little bit of work you did, the potential and kinetic energy? That was our starting point. It was just a small, everyday transaction of energy on a human scale.
And now, I want you to look up. Think about the sun. The sun, and every single star you can see in the night sky, is basically a giant nuclear furnace. It's constantly converting its own mass directly into light and heat, using that exact same rule, E equals mc squared. Just think about that for a second. The very same principle that explains what happens when you lift the cardboard box is also what sets the entire universe on fire.
And that brings us to the biggest takeaway of all. Energy isn't just something we use, like gas in a car. It's much, much bigger than that. It is the fundamental currency of the entire universe. Every single thing that happens, from a thought in your brain to a star exploding, is just an exchange of this currency, a transaction moving from one form to another. And now, we humans have figured out how to unlock the most concentrated form of this currency there is, mass itself. We've seen its incredible power to build and create, and its terrifying power to tear down and destroy. So that leaves us with a pretty big question, doesn't it? If energy really is the currency of the universe, how are we going to choose to spend it?